Now, one complication. In this example, I deliberately made up the example so that it could be factored easily. That will not always be the case. So if you can't factor a quadratic equation, you can always use a quadratic formula. And let me just give the quadratic formula. And let's switch from p to x, because the quadratic formula is given in terms of x instead of p. Let's assume you have an equation of this form. A x squared plus bx plus c equals 0. Where the variable here, your variable is x. And a, b, and c are parameters. A, b, and c are parameters. And there's no restriction really on a, b, and c other than in order for this to be a quadratic equation, we don't want a to be 0. A is 0, then notice what kind of equation is it? If a were 0, then what kind of equation would this be? Be a linear equation. So we want, the only restriction really is a is not 0. In other words, x squared appears in your expression. So let's just assume we have that restriction. A is not 0. It could be positive or negative. Whenever you have an equation of this form, you can work it out algebraically. And the derivation is given in the book. There are two roots, two solution values for x. They are x1 star, comma, x2 star equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, in our problem right here, we have p instead of x, okay? But just making that change, what is our value of a? 1. Okay, so we have a equals 1 in the problem we just did. What's our value of b? 10. And what is our value of c? Yes, negative 200. So if you had a problem like this and you couldn't see how to factor it, then you could just use the quadratic formula. This formula right here. And notice if I just substitute into the quadratic formula, instead of x1 star, x2 star, it's p1 star, comma, p2 star. Equals minus b, so it's minus 10, plus or minus the square root. B squared is going to be 100. 10 squared is 100. Minus 4. A is equal to 1. C is equal to minus 200. All divided by 2. So, if we just continue this, notice what we get. We get minus 10 plus or minus. And that's the plus or minus gives us the two different roots. One for a plus, this is the other for a negative. So this is 100. This is minus 4 times the minus 200 is 800. So we have the square root, 1 square root. If we add it is 900 over 2. So the two roots, the square root of 900 is what? 30. So if we add this, we get minus 10 plus 30, that would be 20 over 2. That would be our 10. Okay. If we subtracted it, minus 10 minus 30 would be minus 40. Over 2 would be minus 2. So you see, if we disregard this one, this negative value for price, we get the same answer. P equals 10. Okay. So you can solve these nonlinear models using the same process of elimination variables. It's just a little more tedious.